Good evening, everyone.
Good evening.
So we are going to start the session. Uh, Dear authors and invited guests, welcome to the technical session 15A. Myself, Arati Mohan, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 10th International Congress on Information and Communication Technology ICICT 2025, London, UK. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held on 18th in London, and the virtual event is being held through Zoom from 19th to 21st February 2025. I hope you all would be enjoying this knowledgeable and interactive session through the day. In this session, we have 6 presentations. Each presenters will be given 12 minutes for the presentation and 3 minutes for the question and answer session round. On 10 minutes, I'll raise a general reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any sort of query or any update, you can write it to me in the chat box. Just before we get started with our session, I would like to introduce you to the chairs for the session. We have Dr. Sachin R. Jain. He is an assistant professor at Oklahoma State University, United States. He has presented and published 20 plus research articles in international conferences and journals. His area of interest includes wireless sensor networks, artificial intelligence, Internet of Things, pattern recognition, and digital image processing. It's a pleasure to have you on board with us, sir. Thank you
Thank
so
you.
much for joining.
Thank you so much.
We have Dr. Anuradha. She is currently working as an assistant professor at Department of CSE Artificial Intelligence, Vishwakarma Institute of Information Technology, Pune. She has published more than 30 research articles, reputed journals with SCI, Web of Science, Scopus Indexing. She has also published many book chapters and patents. Her research interests include data science, machine learning, artificial intelligence, deep learning, and parallel computing. It's a pleasure to have you on board with us, ma'am.
Thank you
Before
so
we
much.
thank you, ma'am. Before we get started with our session, I would like the session chairs to share few opening remarks to our participants.
Of course. Thank you very much. Ladies and gentlemen, dear participants and distinguished guests, it's my honor to welcome you to the 10th International Congress on Information and Communication Technology 2025. As a session chair for this session, I am delighted to witness such a diverse, talented, and accomplished group of individuals gathered here, representing a wide array of backgrounds and expertise from around the globe. Over the next 2 hours, we'll have the opportunity to engage with a wide range of topics spanning disciplines and continents, all united by a common goal, that is the advancement of knowledge and innovation. I encourage each of you to take full advantage of this unique opportunity, engaging with your fellow attendees, participants in the discussion, and explore new ideas. Together, we have the power to inspire change, drive progress, and make a lasting impact on our world. Without further ado, let us begin with the session. May it be a time of fruitful and enlightening discussions, valuable insights, meaningful connections, and new discoveries. Thank you so much.
Thank you, sir. Thank you so much for your valuable remarks. I would request Dr. Anuradha ma'am to share her insights too.
Yeah, thank you so much. So it's my pleasure to welcome you all to this session. And without further ado, I encourage all the participants who have joined this call to participate very actively and please have the thoughtful discussions here, engaging discussions. So thank you so much for giving the opportunity as a session chair.
Thank you so much, ma'am, for your valuable words. Moving on to our first presentation, we have the paper title Agri-Predict Threat Assessment Model for Agricultural Management. Dear presenter, could you please proceed with your presentation? I repeat, the paper title Agri-Predict Threat Assessment Model for Agricultural Management. Dear presenter, could you please start with your presentation? Moving on to our next presentation, we have the paper title Analysis of Vehicle Traffic Trends Using the Social Network, Twitter, Case Study, Quito, Ecuador. I would request the presenter to please present his paper. Thank you.
Okay, you are looking my screen now.
Yes, your screen is visible. You may please start.
Okay, thank you. My name is Steven Gomez. I represent to the group of research in Quito, Ecuador. We are going to analyze the vehicle traffic trends using Twitter or X now, a case of study with applying different techniques. Agenda is a review, introduction, related work, methodology, vehicular traffic detection system architecture, results and discussion, conclusion and recommendations. Quito, Ecuador is facing several traffic congestion due to population growth. Despite several initiatives like traffic control system, peripheral roads, congestion persists, and a proposed low-cost app aims to Twitter or X data and traffic records to identify and address real-time traffic issues. Context. Quito, Ecuador is the capital of Ecuador, faces traffic congestion due to high population density, topographic challenges, and rapid vehicle fleet growth. The city's unplanned expansion from north to south exacerbates this issue. Various strategies, such as pick and license plate policies and intelligent transportation, have been implemented to address transportation issues. However, these initiatives have often insufficient and costly. A low-cost application is proposed to collect, store, process, and visualize unstructured traffic data in real time. Using big data tools, it supports decision-making for traffic congestion using sensors data and Twitter or X social network for real-time updates. So we can provide real-time information on traffic and application for functionality. That's the principal idea. This study have analyzed traffic congestion in Quito and explored using Twitter for detection. Field research and social network analysis supported the proposal. Evaluate three hypotheses about time, Twitter, effectiveness in detecting congestion. So the methodology is research to understand population perception of the heavy traffic using social network. And we have several findings in order to adjust our hypothesis. Related work. We have several analysis of includes image correction techniques, intelligent transportation, social network times, that were analyzed in this work. We have indeed developed a systematic review to address traffic congestion. Several cases globally we have analyzed, and we conduct a research investigation about collecting information through bibliographic analysis, including primary data from governmental institutions and secondary sources like articles and websites. Traffic congestion is the major issue, so surveys were conducted to evaluate using Twitter as traffic alert tool. The inductive method and stratified random sampling were used for cover 10 strategic points and a sample of 384 people is our sample size. System architecture overview. Over here we have different aspects. For example, we have data provider. In this phase, traffic sensors, agents, social network, and HDFs, Hadoop distribute file system. On architecture provider, we have principal HDFs, and we have Roger and nodes for security. In the central part, we have application provided with Flume and Scoop for collection phase, integration phase with HBase and Hive, and analysis out. We have a data consumer with Cardi and orchestration system with Yarn, Abari, Zookeeper, and Uzi. So we have information value chain, and the value in general, value chain for IT. In this topic, we have to analyze that this architecture has been tested with several data, and various data sources provide information on traffic congestion, including Serson data, agent reports, and social media. This data is stored in HDF file system and SFTP for integration and transfer to the main server. Okay? So the social media collects information about traffic incidents effective in road traffic congestion management. And HDFs acts and data provided for other components. In addition, we have this data collection for processing. We have the process of indeed of cleaning, the structure of feature extraction, I mean, and we have divided the corpus in 20% for testing and 80% for corpus training. We have applied naive bytes for analyzing this information provening from tweets. And as a result, we have congestion situations in heavy traffic. Okay. The context is that we have Apache Flume and Scoop for user data collection for analyzing this impact in the city. Data consumer. In Big Data Life, as you know, one of the phases involves publishing results using visual tools. process data, but we use CartoDB integrate with Apache Hadoop. Okay. Orchestration system, we have management large volume of data, and we have horizontal using multi-nodes. Container clusters to help abstract complexity in Hadoop Yarn, Apache Ambari, and Zookeeper that are the key tools for application and architecture, managing and processing coordination. Security and privacy, we have embedded require tools for authentication and encryption. So Apache Rangers offer granular authorization, and Apache nodes ensure network access. Of course, we have this research was conducted in 3 stages, from April to March 2024, in total of 85,983 tweets were data general compared from Twitter data coverage and sensor data coverage. See, in Zoom, we have the study use vehicle flow sensors, offer reports, and tweets to detect congestion. In total, we have 10,427 congestion events were not treated, while 8,952 were reported by 2 tweets. In total, 17,904 tweets were detected. So, the analysis covers traffic data, sensor, and trend model was used, applied to all these intersections. That is tables showing model coefficients and error metrics. Here we have the distribution of vehicular traffic and the results in linear regression. Insights with vehicle flows and congestion level. Findings. This study analyzed traffic and traffic sensor. We have explained. Key findings include 68,305 with 74% identified. So we can see now that this is a perfect and low-cost tool for identifying congestion cases. In 74 is very high. Of course, with different other studies in London, Japan, and others, but there are unique aspects of topography and the infrastructure that's very complicated because of that we have a very high traffic. But on the other side, we have innovative solutions involving social network and practical implications. Integration with traffic sensor facilitates informed decision to try to and also reducing the expensive sensor infrastructure. We have under representation events. Well, in order to save, I'm going to this, the time are challenges. Twitter can be better for two traffic management despite challenges, irrelevant data, and frequency variability. Sensor was, this is very important. Specificity hashtag combining natural language processing and would be condition predictions in adverse weather.
A presenter, sorry to interrupt. Could you please conclude your research? Yeah.
This study has data and Twitter for management. Twitter data of special coverage and for traditional system. Challenge data high quality filtering. In Quito, unique challenges must be considered. High correlation between Twitter and sensor data improves accuracy, especially natural language processing techniques. And future, we can improve this by categorization better integrate navigation app for comprehensive explore machine learning to predict traffic using historical, social, questions.
Yes,
Maximo.
thank you, Dr. Gomez, for the nice presentation. So I have, yeah, hope I'm audible. So I have a single question, like how can your research be applied in the real world scenarios or in the industry settings? Can you answer, please?
Your question is about different scenarios or the data. What is your question about?
That's about real world scenarios. So you can consider any of the applications where your research can be applied.
Well, we have over here different sources that we can manage, not only social network, but also we can manage, for example, cameras or sensors around the city in order because we have a system of control system used by several authorities or transportation, and we can use this in order to get additional information and process in order to improve the transportation system and the heavy traffic indeed. Cross this information with social network would be a better solution.
Hello, Dr. Gomez. I have a question. How will the effectiveness of the application be measured and evaluated in your case?
Could you repeat the question, please?
How will the effectiveness of the application you are developing be measured and evaluated? How you are going to measure it and how you are going to evaluate that the application you are thinking of?
Okay. A comparative analysis have been developed between the prediction using Twitter or the social network and sensors. And if there is a coincidence of around 80% of sensors and social network. So it demonstrates that social, many people is taking information about what's going on, and this issue is comparing sensors and the information that and there's a consideration an average of 80%.
Thank you.
Okay.
So yeah, Aarti, before
Yes, ma'am.
we move ahead, can you please restrict to the time limitation? Yeah.
Yeah, sure.
Okay, thank you very
Thank
much.
you. Thank you so much for your presentation.
Thank you.
Moving on to the next presentation, we have analyzing the structure of groupoids of order 3, 4, and 5 using PCA. Dear presenter, could you please start with your presentation? I repeat, the paper title, Analyzing the Structure of Groupoids of Order 3, 4, and 5 using PCA. Dear presenter, could you please start with your presentation? I repeat the paper title. Are you there in the meeting, dear presenter? Analyzing the structure of groupoids of order 3, 4, and 5 using PCA.
Yeah, I can see Alyssa in the meet. I don't know if she's not able to
Yeah,
unmute. I don't know.
right now, I think she has shared the
Yeah,
presentation.
okay. Okay. All right.
Okay, we can see your presentation. Could you please start your presentation and please adhere to the time limit. I'll raise a gentle reminder after you complete 10 minutes. So please adhere to the time limit. Thank you. Moving on to our next presentation, we have berthing vessels against wind turbines in a real sea state. Dear presenter, could you please start with your presentation?
Can you hear me?
Yes.
Yes, yes.
Okay, I will try to share the presentation. So it has been a while since I used Zoom. So how do I share with Zoom? You know? Partager.
Yeah,
Okay,
there's
okay,
a
I got it, I got
icon
it.
to share. Yeah, yeah, okay.
I got it. Thank you. Sorry for that. Okay, let's start. Can you see it?
Not yet. Yeah, we can see.
Okay. So let's start. Tell me if there is any issue. Can I start?
Yes, please.
Okay, so this paper is about berthing vessels against wind turbines in real sea state. So to start with, let's understand what a real sea state is. It is also called irregular wave, which is actually, if you look at the sea surface, the sum of the elevation of several sinusoidal waves from several directions. So the formula on the top left is the general formula giving the wave elevation for an irregular sea or real sea state. If you look at now at a particular location, which is, for instance, at the origin of the system of axis, the formula gets more simple. So that is about the wave generated by the sea state. Now let's talk about the phenomenon of berthing a boat against wind turbine. So in this calculation, we investigated a wave coming from the left to the right. On the left-hand side, you have the wind turbine with the ladder for the access to the wind turbine. On the right-hand side, you have the boat looking from an elevation, sorry, from a top view. There is an interface between the two, which is the deformable fender. Actually, this fender has two interfaces. One with the ladder, which is the boat landing or fender interface, which is a point called M_C. On the right side, you have another interface, which is the boarding points from the vessel side. which is called A minus. So these 2 points will be used for the subsequent calculation. Please bear in mind MC on A minus. One phenomenon which will make more complicated the berthing is the boat surge, which is the horizontal motion. Now, it is locked. Oh, sorry, there is some time lag. Looking from an elevation, so the photo was taken from the boat, looking at the wind turbine. So what you see is another phenomenon which is making complicated the berthing is the boat heel, which is the vertical motion of the boat at the boarding point where the man stands. Such motion causes the fender from time to time to slip with the vertical motion Z underscore MC. We have to prevent that slip to be more than one ladder rung. It is a regulation which says actually that 95% of the waves should not exceed more than one ladder rung fender slip. Now looking at the mathematical model. So it is a combination of horizontal vertical springs, horizontal vertical dampers, and vertical friction force. These forces model the interface between the boat and the ladder of the boat landing. Looking at the equations now, if we start by looking at the seakeeping equations for a boat in irregular seas. So let us forget the boarding phenomenon, just a boat alone. It's quite a complicated equation. Why? Because when a vessel moves in a regular sea, it has to face the sea state from the previous waves. So it's called history. There is a memory effect. So this memory effect is accounted for by integrals. So you see here an integral, which is for the first formula on the top of the slide. On the second line, you see two other integrals. So the first one actually is called retardation function. This is the function which provides this memory effect. And it is used in two different terms. The first one is Ij for infinite, where this integral is used. And this integral is also used in the top equation with an integral from infinite to time t, to instant time t. Well, now, after investigation looking at the boarding, it occurs that boat motion history has little influence, so that makes the equation more simple. That equation causes that the integral of Rij sinus omega t tau is negligible, while the other integral can be simplified to another integral, which we call Bijm, which is a kind of an average. While omega t is the pulsation of the sinusoidal waves, which corresponds the best to the irregular wave at the instant t. So in fat characters, you have the resulting equation, which is more simple. Basically, you get closer from the equation for a simple sinusoidal wave on the left-hand side, while on the right-hand side of the equation, it is just simply the addition of the forces due to each of the sinusoidal waves making up the irregular wave. Now, so if we look in the matrix point of view of the equation, so that is the same equation, but looking at how it stands in the matrix. So there are plenty full of zeros, which is good news because there are a lot of symmetries in the boat hull. So that is for the left side of the equation. For the right side, the effort F are a combination of two forces which are due to the seakeeping of the boat, float, krill off, and deflection, plus the mean force of the propeller, which is used to put the boat against the ladder, there is the spring, which is the mean spring force due to the spring modeling the fender, the mean damper force, which is the dampers modeling the fender, and then the force is explaining the variation in the propeller thrust, variation due to the pitch of the boat, which is the inclination of the boat. Now, another equation is the equation modeling the mass, which is modeling the fender, which is called m star. So this equation is related on the right side of the equation to the friction force on the vertical friction force on the vertical spring and damper forces. Actually, in the other equations, we are going to simplify the notations, and we will call FKBX the sum of the horizontal spring and damper force, and same for the vertical forces. Now, with all of this, we can make it simple to use MATLAB and Simulink by putting it into a state space model. So we come back from the second order differential equation into a first order, which can be calculated by Simulink on MATLAB. A is the matrix of the unperturbated and uncontrolled boat dynamics, so which is without contact. F is the vector which actually includes the contact dynamics, but also the propeller force. So the dynamics are modeled by the spring dampers and friction. While E is actually the perturbation, which is actually the hydrodynamic force, so the action of the waves. This is a quick look at the MATLAB Simulink model. So it gets a little bit more complicated than last year when I did the same presentation. So talking about the results, that result is for 1.5 meter significant wave height, which is a kind of average wave height. What you see in blue is one ladder rung, which is 0.3 meter. In green, in red, you see the boarding point heave variation. So variation in time in red. In green, you see the fender heave variation. So what you see is a succession of steps. Why? Because with such a low wave, there is static friction, which is that it means that the fender stays stuck against the ladder, so it does not move apart from some times where there is a bigger wave coming. So for that particular calculation, we find indeed that more than 95% of the wave pass with no slip below one ladder rung. No, that is not the same if we go into heavier sea state, which is 2 meters significant wave height. As you can see here, the curve is more significant. There is bigger amplitude, which reflects the 2 meter sea state. And you see that the number of steps, there are more steps where there still is static friction, but for a smaller duration. So all in all, we find that less than 95% of the waves pass with no slip above one ladder rung, which makes it unsafe to board. To summarize in the table, so this is a table from another publication which gives a benchmark.
Dear
Circuit
presenter,
evaluation out.
sorry
Yes.
to interrupt. Could you please conclude your research? You have 2 more minutes to conclude.
Thank you. So that benchmark says that actually there is not only the sea state which matters, but also the ratio of the wavelength, which is the length between two wave crests, and the boat length. So approximately, if that ratio is below 2 meters, you can still board with 2 meters significant wave height, while above, you can only board with 1.5. So as we noted in the 2 slides before, actually, we found out that we can only board with 1.5 meters significant wave height. Why? Because our calculation faced some convergence issues when we try to investigate the low wavelength over boat length values. So our interpretation is that it may be related to the issue of the modeling the fender with springs, which may lead to resonance. So we are actually investigating another model, which is called pseudokinetic. So as far as we stand, only 1.5 meter significant wave height meets the other publication that we use as a benchmark. that's it from my side. So if you have any questions, please feel free. Yes, so another step for the future is to optimize fuel consumption by fine-tuning the propeller thrust. Sorry for that.
Yeah, thanks, Laurent, for this presentation. Have you compared your result with the existing techniques or any models?
Oh, yes, that is the other benchmark I was referring in the conclusion. Yes, correct. So actually, that benchmark is based on not only calculations, but there is another benchmark which use the tests as well. Yes. So
Okay.
C tests,
Okay.
offshore
Okay.
tests.
Thanks.
Hello.
Yes.
Have you done the field testing for this?
Not myself, no, but that was another
So
publication.
how you are going to like do it for the real world validation of the proposed strategies?
That is not my purpose. I mean, my purpose is more to get into better practices for fine-tuning propeller thrust, because as it stands, the captains just apply maximum thrust, and there is a lot of cost saving to cut out of this, not speaking about gas emissions.
So are there any limitations of your studies? Like, are there any factors that you have not considered for your studies, like out of the box?
Oh, well, we could think about a multidirectional C-state. This C-state is only unidirectional. Yes, because typical C-state, well, I mean, in Europe at least, is a combination of two wave directions.
Okay, thank you, Laurent.
Pleasure.
Thank you. Thank you so much for your presentation. Moving on to our next presentation, we have the paper title, Breast Ultrasound Imaging Classification Using Federated Learning Techniques.
Hello,
Dear
good evening.
could you please start with your presentation?
Sure. Yeah, good evening, everybody. My name is Amr Saleh. I'm a PhD student at Princess Sumaya University for Technology in Jordan. And today I will be presenting our research titled Breast Ultrasound Imaging Classification Using Federated Learning. And my co-author is Dr. Naila Al-Madi. This study explores how federated learning can improve breast cancer detection while preserving the privacy and the patient data, given the sensitive nature of medical data. So in this research, we aim to build AI models without centralizing patient records, making machine learning safer and more practical for real-world health applications. So this presentation, we first introduce the problem statement and explaining the motivation behind our research. And next we will cover federated learning, its concept and benefits briefly. Then we'll dive into our methodology and architecture, describing how we have implemented the federated learning for ultrasound imaging. And moving forward, we'll discuss the data pre-processing and the data sets used in the research, including the techniques. And finally, we'll discuss the results and discussion and the key findings and the comparison with other traditional machine learning. And we'll mention also the challenges and future work for our research. First of all, breast cancer is the most common cancer among women, and it's a leading cause for cancer-related deaths. And according to the World Health Organization, it was responsible for more than 600,000 deaths in 2022 alone. So early and accurate diagnosis is crucial for increasing survival rates. Here, ultrasound imaging plays an important role in breast cancer detection due to its affordability and safety. However, the accuracy of ultrasound diagnosis depends almost on radiologists and doctors' expertise. So AI here can help by providing automatic classification, and traditional machine learning, as we know, require centralizing the data, which raises some privacy and security concerns. Medical institutions, usually like hospitals, store patient data in separate silos due to strict privacy and regulations such as GDPR. So this making transferring the data to a centralized location for cloud computing location, for instance, for AI training, impractical and make some risky. So federated learning here solve this by training models without any data sharing. This diagram represents the traditional approach in machine learning, which is known as centralized learning. So in this setup, from multiple client devices, we collected the data, and the data is transferred to the central server, where the training for the machine learning model is happening, and all the combined data sets are batched together in the central location. This approach can be effective, but raise several key challenges. As we just saw, the centralized machine learning has significant limitation with privacy concerns. These challenges make it impractical for a sensitive application, where data cannot be freely shared between institutions. To overcome these obstacles, we have introduced the federated learning approach, which is a decentralized approach that allows multiple organizations to train and share a machine learning model without sharing the raw data. So instead of sending the data to a central server, federated learning can enable each client to train the model locally on their own data. And after the training, only the model updates, not the raw data, are sent to the central or aggregator server, where the aggregation to improve the global model is happening. This process can ensure that the data remains private and secure, and can achieve privacy preserving and security enhancements in machine learning model. Moving forward, this diagram illustrates how our approach using federated learning process is implemented. Unlike the centralized learning, we enables federated learning to train directly each client on its device while preserving the data privacy. So the process works here in 6 steps mainly. First, the central federated learning server initializes the global model and shares it with participating clients. And then each federated learning client can train the model on its own local data without sharing any data. And once the training is completed, clients can send their updates model weights only to the central server, and the server can aggregate these updates using federated averaging approach or any other different approach to refine the global model. And the improved global model is sent back to the clients. And this iteration is repeated until the model converges to an optimal state. So this ensures that the model learns from diverse data, distributed data sets while maintaining data security and compliance. Regarding the data sets that we have used have used 3 data sets actually, and the data consists of breast ultrasound images classified into 3 classes: benign tumors, malignant tumors, and normal tissue. And to improve the performance of the model, we have applied data augmentation techniques such as image flipping and rotation to increase the training data set, because we have used a deep learning model. So we have expanded our data set to have more than 2,000 images, which can improve the model generalization. different pre-processing techniques applied as well to remove the noise from the ultrasound images, like speckle noise. We evaluated our federated learning model against a traditional centralized model, and the key performance used here were accuracy and F1 score to make the balance between precision and recall. The federated learning model achieved 82% for accuracy and 78 as F1 score. These results demonstrate how the federated learning performs competitively with the centralized model while maintaining the privacy. Again, this slide presents the performance over the 10 training rounds for the federated learning process, which highlights the key metrics like accuracy and F1 score and loss. So looking at the table, we observed a clear improvement in accuracy and F1 score through the rounds. So initial rounds, the model starts with low accuracy. Then in the middle rounds, 4 to 6, there is significant jump in accuracy. And in the later rounds, the model gradually stabilized and reaching its peak, 82% accuracy and 78 F1 score in round 10, which indicates the successful convergence of the model. While the federated learning has proven efficiency, there are still several challenges remain, like the communication overhead, where the federated learning will require frequent updates between clients and the server, which increases the network traffic. Using the non-IID data, where each institution or client has different patient demographics and imaging conditions, which can lead to imbalanced training data. Also, some computational constraint by running the local training on each device, which requires optimization. For future work, we plan to work on optimization for federated learning aggregation strategies to improve the performance and reduce the communication overhead. In conclusion, this study demonstrates the federated learning, where it's a viable and effective solution for privacy preserving breast ultrasound image classification, and it can achieve a competitive accuracy while protecting the patient data. Thank you.
Okay.
And if you have any question, please feel free to ask.
Yes, thanks. So you have considered here 3 data sets as you have mentioned on one of the slides. So have you compared the results on all 3 data sets?
Yeah, actually, basically, we have used 2 data sets for training purposes. We have made a partitioning for the training data sets across the clients participating in the federated learning approach. Okay, and the third data set was used for testing purposes only to make sure that the model is generalizable enough for the training. So these are the 3 data sets main usage in our approach.
Okay, thanks.
So you have any questions?
I have one question actually. Could you extend more about this convolutional neural
convolutional
network,
neural networks, CNN?
please? Yes.
Yeah, it's thank you. It's a machine learning approach that basically used for imaging. Okay, it's used for classification. For instance, it will use what we call it convolutional neural, where we can apply different kernels on each image. Will be partitioned across 4 different regions, and we apply a convolution on each part of the image to extract the features. In this approach, no need to use any feature engineering or manual feature extraction. It will extract the features automatically. it's widely used in images, basically.
Okay, it's out of interest because it don't have anything to do with your field of expertise, but we also use convolution kernels, but they are talking more about memory effects.
Mm-hmm.
So that does not sound the same application. But anyway, thank you.
No problem.
Hello, Amro.
Hi.
My question is, how was the breast ultrasound image dataset was collected and it was annotated? How do you did the annotation of the collected dataset?
Yeah, actually, we have used, thank you for the question. We have used public data sets, 2 public data sets, and third one is private one. For the 2 data sets publicly available, they have included the annotation for the tumor, for example. It's segmented already on each picture. So each image has its own segmented part, but done manually by doctors, okay, for all the data set. And the same approach applied for the third data set as well. We have collected this data from a local hospital here in Jordan, and it's already annotated as well by doctors and radiologists.
Okay, I have one more question. How many clients you are talking about like participated in the federated learning training process?
Yeah, in our experiments, we have used only 5 clients due
And how does
to
it
some
impact the
constraints. Yeah.
how does the client impact the federated learning process? Can you just give a short introduction of that?
Yes, actually, if we have a large number of clients and we have non-IID data distribution across the clients, this will hinder the model accuracy. So basically, we have 2 kinds of federated learning approaches: the vertical and the horizontal. In this case, we are using horizontal, where all clients have the same features, let's say, with different instances of the data. The complexities will come when you use vertical data, where each client has its own set of features. Okay, so if one client has maybe some bias for one class, this will also hinder the global model training as well.
Okay, one last question. Did you
Yeah,
find
please.
any limitation of the proposed federated learning approach?
Actually, the main challenges were the communication overhead, where the limitation of the resources maybe stopped us from continue to improve the model accuracy and performance, because the communication overhead was high. Especially, we are dealing with images, and we have a large number of images, and we have also applied CNN, which also requires high specs of resources. So basically, the communication overhead and each client training on their local data also required a high computational resources.
Okay, thank you.
No problem.
Thank,
You're welcome.
thank you. Thank you so much for your presentation. Moving
You're
on to
welcome.
our
Thank you.
next presentation. We have the paper title Toward an Integrated Health Volunteering Framework to Aid Decision Making in the Context of Hajj Pilgrimage. Dear presenter, could you please start with your presentation?
Okay. Good afternoon, everyone. It is a pleasure to be here at the ICICT 2025. I am Mohamed Tounsi from Al University. Today, I will present a work prepared with my colleague, Ahmed Harithi. So this work discusses healthcare challenges during Hajj. As you know, Hajj is one of the largest mass gatherings globally, presenting significant healthcare challenges. To address this, we propose the integrated health volunteering framework to aid decision-making and coordinate volunteer to foster emergency response. Okay. Hajj with over 1.8 million pilgrims in 2024 present major healthcare challenges. The other important point is the extreme heat in Mecca city, the place where performed the Hajj. So the other thing is the crowd density is very high, and long working distance increase medical risks. In 2022, Makkah hospitals treated more than 97,000 pilgrims. And unfortunately, in 2024, there is more than 1,300 deaths were reported, many due to heat-related issues. So these numbers highlight the need for a faster, more efficient emergency response system. This is where our framework comes in. We mentioned that the Saudi government plays an important role in ensuring healthcare during Hajj by providing free, comprehensive medical services. Also, significant investments have been made in e-health infrastructure. For example, applications like Sahati and Safni offering remote consultation, appointment scheduling, and access to personalized health data. Despite these efforts, there is still large need for improvement. We propose to integrate volunteer efforts. We think that we can enhance emergency response and overall healthcare outcome. So our work and our framework focuses on three key objectives. The first one is to improve the emergency warning system. The second one is to assist in triage and first aid supporting patient care. The third one is to enhance blood donation coordination. By leveraging technology and volunteer, we aim to create a more efficient and responsive healthcare system during Hajj. Okay. The integrated healthcare volunteer framework consists of 6 main components that work together to enhance emergency response during Hajj. The first are bystanders and AI camera detection. Play a key role in triggering alerts and assisting before medical team arrive. Then the second one is the emergency service, including official medical teams coordinate urgent interventions. Third one is the IHV application, connects volunteers with incidents in real time. The fourth is health volunteer, such as doctor, nurse, and a blood donor provide immediate medical supports. And it is important here to mention that health volunteers are majorly are basically from Hajj pilgrims. Patient are the five. The number 5 is the patients are the pilgrims in need of care. And finally, the professional emergency system or professional emergency service, teams handle critical cases upon arrival. So now let's see how the EHV or our framework operates in real emergency scenario. We distinguish 3 cases. Let's start by the first one. So the first case handles urgent blood donation request. How it works. So the first step, as you see here, okay. The first step will receive alert from a hospital or a blood center for a specific blood type on the location. The second step will search volunteer. The system search for registered blood donors neighborhood and notify them via the framework application. The third step here, so we'll receive feedback. Volunteer can accept or decline the request based on their availability or willingness. Finally, the fourth step, the monitor the emergency. Once the volunteer accepts, the system guides them to the donation system centers. So the second case Okay, in case 2, our framework uses AI-enabled camera to detect some emergency cases. For example, a person not moving for a lapse of time, a pilgrim collapsing. Okay, when the AI system identify a potential crisis, it immediately alerts nearby health volunteer. Volunteer assess the situation and provide initial care if it needs, and the more precise information about the patient's situation. Finally, the framework coordinates with the professional emergency service based on received informations from volunteer to ensure ensuring that the emergency service are ready to take over upon arrival. Finally, the third case, our framework handle emergency reported by bystanders. Okay, when a bystanders alert emergency service, the framework identifies and notifies nearby volunteer who can provide urgent intervention before professional medical teams arrive. So volunteers assess the situation, relay critical information to emergency service, and ensure continuity of care. Once professional help arrives, they take over, ensuring a seamless transition from initial response to advanced medical treatment. Okay, to ensure the IHB framework operates effectively, we focus on validation and accuracy assessment. The key evaluation metrics include, for instance, the response time and volunteer effectiveness. We also
Can you please
emphasize.
move to the results?
Okay, the last slide. Okay, the next slide will be the last slide. We also emphasize, to be late. Also emphasize training program and robust feedback system, and finally recognize and incentive encourage volunteer participation. Okay, finally, in conclusion, we propose a framework to address the critical healthcare challenges during the Hajj pilgrimage. By leveraging advanced technology like AI and mobile application, we aim to improve emergency response time and reduce facility during the Hajj pilgrimage. As a future research, we will focus on integrating predictive AI analytics to assess health risks and incorporate wearable health monitoring device for real-time patient data. This advancement will further enhance the framework ability to save life and ensure the safety of pilgrims. Thank you.
Yeah, okay, Mohammed. So you have proposed some two models, but you have not shown how they are working, like maybe in terms of results. Have you evaluated those proposed work?
Okay, this is a design. It's a step of design. We did not implement this framework
Okay, so you have
because we need some sensitive data. We cannot get it. It's not easy because they consider it as private data. We can ask it from here administration responsible on Hajj and Umrah, but almost we need a project, and we are preparing a project for that to get all the needed data to do all the needed implementation.
okay, all right.
Okay.
Hello, Mohammed.
Hello.
Yeah, I have a question. Like, what are the other common health risks and emergencies you have considered other than the blood donation or like requirement of blood? Other than that, what are the other emergencies you have considered in your study?
Okay, we did not consider a special case study, but the common case is blood donation because we need donor from everywhere. The second case, the second and most important point, the volunteer should have how you say should share the culture and the language with the patient, because as we see, there is a lot of volunteer here in Arabia Saudi, but most they are coming from they are Saudi people. What we propose here is to introduce volunteer from pilgrims, means that from other culture, from other language, from around the world. This is the key point of our framework.
Okay, so as the Hajj, the pilgrims are from all over the world. Does the IHP framework consider the language and cultural diversity? Because
Exactly.
it may
Yes.
have from that the pilgrims may be from the multicultural, and so have you implemented or considered the diversity in your IHP framework?
Exactly, yes. You mean that our framework support multi-language, our framework support,
Yeah.
yes, should be like this, yes. Yes.
Okay, so like this is, I think, in the initial phase right now, or you have done some implementation part as well?
No, that's just initial phases. So we just need to propose a project now. There is a special administration for that. And if our project is accepted, we can go ahead and we can implement and get the real results.
Okay, thank you, Mohammed.
Thank you.
Thank you. Thank you so much for your presentation. This brings us to the end of our presentations. I would request our respected session chairs to share their feedback on the presentations which have been uh, presented. Respected sir, ma'am, could you please share your insights, please?
Yeah, so
Yeah.
first of all, I would like to congratulate all the researchers for sharing their research here and contributing to this ICICT to 2025 conference. So with this, would like to wind up my part. Yeah, thank you.
Thank you so much, ma'am. Thank you for your valuable words.
Yes,
Thank
and
you,
from my
Arti.
side, I also noticed there
Ladies,
was a lot of machine learning topics. Sorry for interrupting.
no worries. Please go ahead.
Yes, no, I just noticed that there is a lot of papers talking about machine learning topics, of course.
Okay, ladies and gentlemen, dear participant and distinguished guest, as we come to the end of the session, I would like to extend my heartfelt thanks to each of you for your active participation, insightful contribution, and engaging discussion. It has been a truly enriching experience to witness the depth of knowledge and expertise present in the session. I would be remiss if I do not acknowledge the hard work of and dedication of the conference organizers, sponsors, and volunteers. Your tireless efforts behind the screen have been instrumental in making this event successful. Thank you once again for your participation and contribution. I look forward to our path crossing again in near future. All the best. Thank you so much.
Thank you, sir. Thank you so much for your kind and valuable words. So, I sincerely thank all our authors for their excellent contributions and presentation in this session, and all our participants for being a part of this international conference. I hope this session was informative enough, and we, on the behalf of the whole team, would like to thank you for the support during this 10th version and all the previous 9 versions of the conference. We would be really happy to have you all in the 11th version as well. Sorry, 11th version as well in 2026. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICICT 2025. I would like to thank our respected session chairs for chairing this session and providing a valuable feedback to all our presenters. I truly believe that all your insights are informative enough for all the participants. Thank you, Sachin sir, for your valuable presence. I would like to thank Professor Anuradha ma'am for sharing her insights as well. Thank you so much, ma'am, for making your valuable presence. A token of appreciation to our respected chair on behalf of Team ICICT 2025 and Global Knowledge Research Foundation and partners. Thank you, our respected session chairs, for making your valuable presence.
Thank you, Aarti.
Thank you, sir. I would kindly request all the participants to please switch on your camera so that we can have a quick snapshot of this virtual conference. I would request every participant to please switch on your cameras. Thank you. Thank you so much. Stay safe and take care. Bye.
Thank you.
Thank you.